stepping out of a spacecraft and having only 5 seconds to exist. No countdown, no warning, just a door opening onto the most hostile world in the inner solar system, Venus. At first glance, Venus looks almost like Earth's twin. Similar size, similar gravity, a rocky surface hidden beneath thick clouds. But that illusion collapses the moment you arrive. Because Venus is not just unfriendly, it is violently, relentlessly uninhabitable. The moment you arrive, whether dropped from orbit or somehow standing on its surface, your 5 seconds begin. Second 1. Before you even register what you're seeing, the pressure hits you. The atmosphere on Venus is about 90 times thicker than Earth's, like being nearly a kilometer underwater. Your body isn't designed for this. Your lungs would struggle instantly, not just because of the pressure, but because there is no oxygen to breathe. Only dense carbon dioxide. Second 2. The heat becomes impossible to ignore. Venus is the hottest planet in the solar system, even hotter than Mercury. Surface temperatures hover around 465 degrees Celsius, 869 degrees Fahrenheit, hot enough to melt lead. This isn't like stepping into an oven. It's like becoming part of it. The heat doesn't just surround you, it penetrates. Second 3. You might try to look up, but the sky offers no comfort. There is no blue, no sun shining clearly overhead. Instead, a thick yellowish haze of sulfuric acid clouds scatters the light into a dim, suffocating glow. Shadows are weak. The horizon is distorted. Everything feels wrong. Second 4. Your body is now completely overwhelmed. The combination of pressure, heat, and toxic atmosphere works together with brutal efficiency. Even advanced materials struggle here, which is why probes sent from Earth, like those from the Venera program, survived only minutes at best. And you weren't built for even seconds. Second 5. This is the moment where everything reaches its limit. Your senses fail. Your body cannot adapt, cannot resist, cannot negotiate with this environment. Venus doesn't attack you, it simply exists, and that existence is incompatible with life as we know it. And then, it's over. 5 seconds. But here's the unsettling part. Those 5 seconds tell a much bigger story, not just about Venus, but about how planets evolve, how climates spiral out of control, and how thin the line really is between a world that supports life and one that destroys it. Because Venus wasn't always this way, and understanding how it became a nightmare might reveal something even more important. What could happen to Earth? To understand why those 5 seconds are so deadly, we have to go back billions of years to a time when Venus may have looked surprisingly familiar. There is growing evidence that ancient Venus might have had oceans, not small lakes, but vast bodies of liquid water covering much of its surface. Temperatures could have been moderate, the atmosphere thinner. In many ways, it may have resembled early Earth, a world with the potential for stability. So what happened? The answer lies in a runaway chain reaction known as the greenhouse effect, a process that, on Earth, helps keep our planet warm and habitable. But on Venus, it didn't just warm the planet, it consumed it. As the young sun grew brighter, Venus began absorbing more energy. Any surface water would have started to evaporate, filling the atmosphere with water vapor, itself a powerful greenhouse gas. This trapped even more heat, causing even more evaporation. A feedback loop had begun. Temperatures climbed higher. Oceans boiled away. The upper atmosphere filled with water vapor, where solar radiation broke molecules apart, allowing hydrogen to escape into space. Oxygen either reacted with surface rocks or was lost as well. Venus was losing its water permanently. Without oceans to regulate temperature and absorb carbon dioxide, volcanic activity continued to pump massive amounts of CO2 into the atmosphere. On Earth, carbon dioxide is balanced by processes like weathering and ocean absorption. But on Venus, with no liquid water left, there was no such balance. The atmosphere thickened, the heat intensified, and the planet crossed a point of no return. This is what scientists call a runaway greenhouse state, where a planet's climate system spirals beyond recovery, locking in extreme temperatures for millions, even billions of years. Today, Venus's atmosphere is composed of about 96% carbon dioxide, with clouds of sulfuric acid drifting high above. The surface pressure is crushing. The heat is constant. Day and night make little difference because the atmosphere traps energy so efficiently that it distributes heat across the entire planet. But here's something even stranger. A day on Venus, one full rotation, takes longer than a year. The planet rotates incredibly slowly and in the opposite direction of most planets in the solar system. The sun would appear to rise in the west and set in the east, moving sluggishly across a sky that never truly clears. If you could somehow survive longer than 5 seconds, you wouldn't just be fighting heat and pressure. You'd be standing on a world where time itself feels distorted. And yet, despite all of this, scientists remain fascinated by Venus, not just because of how extreme it is, but because it may hold clues to one of the most important questions in planetary science. How close is Earth to becoming the same kind of world? Because the difference between Earth and Venus isn't just distance from the sun, it's balance. And balance, as Venus shows us, can be lost. If 5 seconds on Venus feel like an instant, then studying it has taken decades, and we're still only scratching the surface. Reaching Venus is not the challenge. Surviving it is. Throughout the 20th century, multiple missions attempted to descend through its dense atmosphere. Many failed before they could send back data. Others were crushed, melted, or silenced within moments. The most successful were part of the Soviet Venera program, robotic landers designed like armored capsules, built to endure hellish conditions. One of them, Venera 13, transmitted data from the surface for just over 2 hours. That might sound impressive until you remember that every second was a fight against an environment that actively destroys technology. The images it sent back are unsettling. A flat, orange-lit landscape, rocks scattered across a surface that looks both alien and eerily familiar. No movement, no wind visible, despite the thick atmosphere. Just stillness, as if the planet itself has been frozen in time, not by cold, but by overwhelming heat. But Venus is not silent. High above the surface, in the upper atmosphere, winds rage at speeds of up to 300 to 400 kilometers per hour, circling the planet in just a few days. This phenomenon, known as atmospheric superrotation, means that while the surface barely turns, the sky above it is in constant, violent motion. It's a world of extremes layered on top of each other. And here's where things take an unexpected turn. At about 50 to 60 kilometers above the surface, conditions change dramatically. The temperature drops to a range that, surprisingly, is not far from Earth's. The pressure becomes more tolerable. In fact, this region of Venus's atmosphere is sometimes described as the most Earth-like environment anywhere outside our planet. Some scientists have even proposed the idea of floating cities, habitats suspended in the Venusian sky, drifting above the inferno below. It sounds like science fiction, but the physics doesn't entirely rule it out. Of course, there's a catch. Those same clouds are made of concentrated sulfuric acid. Even in the habitable zone, survival would require constant protection from corrosive chemistry, powerful winds, and an atmosphere that still offers nothing to breathe. It's not a second Earth. It's a narrow window of less lethal conditions in an otherwise deadly system. And yet, we keep going back. Modern missions, like those planned by NASA and the European Space Agency, aim to map Venus in unprecedented detail, study its atmosphere, and search for answers hidden beneath its clouds. There are even ongoing debates about unusual chemical signatures, hints that raise questions about processes we don't fully understand yet. Not life, necessarily, but something unexplained. Because Venus, despite being one of our closest neighbors, remains one of the least understood planets in the solar system. And that brings us back to those 5 seconds. They're not just a thought experiment. They're a glimpse into a world that forces us to rethink what makes a planet livable, and how quickly that livability can disappear. Because in the end, Venus isn't just a warning, it's a mirror. Those 5 seconds on Venus are over almost before they begin. But what they reveal lingers far longer. Because Venus is not just an extreme world. It's a demonstration of what happens when a planet loses control of its own climate. On Earth, we often think of stability as something permanent. Oceans regulate temperature, clouds reflect sunlight, carbon cycles balance the atmosphere. It all feels self-correcting, but Venus shows that this balance is fragile. The same basic ingredients exist on both planets: a rocky surface, an atmosphere, energy from the sun. The difference is not in what they have, it's in how those elements interact over time. Once Venus crossed the threshold into a runaway greenhouse state, there was no easy way back. No oceans left to absorb heat. No mechanism to pull carbon dioxide out of the atmosphere. The system locked itself into a new equilibrium, one that is stable, but completely hostile to life. And that raises an uncomfortable question. How far is Earth from its own tipping point? Right now, Earth is not Venus. The conditions are vastly different, and our planet still maintains the delicate balance that supports life. But the physics that shaped Venus hasn't disappeared. The greenhouse effect is still at work here, just at a much lower intensity. The lesson isn't that Earth will suddenly become Venus. It's that planetary climates can change in ways that are difficult to reverse once certain limits are crossed. Venus also changes how we look at the universe beyond our solar system. When astronomers study distant worlds, exoplanets orbiting other stars, Venus-like planets appear to be common. Thick atmospheres, high temperatures, clouds that hide their surfaces completely. At first, they might seem Earth-like from a distance, but Venus reminds us how misleading that similarity can be. A planet can look familiar and still be completely unlivable. So when we imagine standing on another world, searching for signs of life, we have to ask deeper questions. Not just, is it the right size, or is it in the right place, but what has happened to it over time? Because habitability is not a fixed trait, it's a story. And Venus tells one of the most dramatic stories in the solar system. A transformation from a potentially water-rich world into a planet where even 5 seconds is too long. If you could stand there, just briefly, you wouldn't witness an explosion or a sudden catastrophe. You would simply encounter a planet that followed its own path to the extreme. No malice, no intention, just physics, chemistry, and time. And perhaps that's what makes those 5 seconds so powerful. Not the danger itself, but the realization that worlds don't need to be far away or exotic to become hostile. Sometimes they just need to change. And once they do, there may be no going back.